You know, when we're trying to solve our biggest engineering challenges, we almost always look to the future. But what if the most brilliant solutions aren't out there waiting to be invented? What if they've already been perfected, patented by nature over millions of years, and they're just waiting for us to notice?
Just picture an environment where the air itself feels like it could shatter. That's the Arctic. Up there, staying warm isn't just about comfort, it's a constant, full-on battle against the laws of physics. It's a problem of pure thermodynamics.
And in this frozen arena, one animal just absolutely reigns supreme: the polar bear. It swims in icy water, it hunts on frozen plains, it's seemingly unfazed by a cold that would freeze most life completely solid. So what's its secret? How has it engineered the perfect defense against the planet's most brutal cold? Now, most of us would probably guess, a thick layer of fat and a really dense coat of fur. And you'd be partly right. But here's what most people don't realize. The true genius is microscopic. It's a level of engineering that's completely hidden from the naked eye.
If we zoom way in, we see that each hair isn't just a simple strand. It's a masterpiece of microengineering. You've got a hollow, porous tube at the core, all protected by a strong, dense outer layer. So think of it less like a simple thread and more like a high-tech fiber optic cable, but designed for warmth.
This design is just brilliant in how efficient it is. That hollow core, it traps air. And air is one of the best insulators there is. The dense shell repels water, which is absolutely crucial because, let's face it, wet fur is useless for warmth. And the entire structure is strong yet flexible, so it won't just snap in that brutal cold. It's a perfect system that completely separates strength from insulation.
Okay, so remember that polar bear hair? Let's put a pin in it for a second, because now we're going to travel from the wild Arctic to a pristine laboratory to look at one of the absolute strangest materials ever created by humans.
It's been called frozen smoke, solid air, and even blue smoke. Its proper name is aerogel, and holding a piece of it is apparently like holding a piece of the sky. Take a look at this number, 99.8%. That is the percentage of this material that is nothing but air. It is, for all intents and purposes, a solid made of empty space. And that's what makes it one of the lightest materials on Earth. And its origin story is just fantastic. It wasn't born from some grand mission, but from a simple bet back in 1931 between two scientists. Samuel Kistler bet his colleague that he could take the liquid out of a jar of jelly and replace it with gas without the jelly collapsing. Well, he won. And in doing so, he invented aerogel. The result of that bet is a material that holds the record for the best thermal insulator on the planet. I mean, you can hold a blowtorch to one side and the other side stays cool enough to touch. It's a modern marvel. Except it has one huge, fatal problem. For all its amazing properties, it's incredibly fragile. It doesn't bend. It shatters like glass. This brittleness, what scientists call friability, has been the one thing preventing it from being used in applications like clothing, where you need something that can actually move with you.
So here's the crucial parallel. We have two materials from completely different worlds, right? And both are masters of insulation because they do the exact same thing. They trap air. But one, perfected by nature, is flexible and strong, and the other, invented by us, is brittle and fragile.
This leads to a fascinating question, right? What if you could merge the two? What if you could give the world's best insulator the durability and flexibility of a system that's been perfected over millions of years of evolution? And this is where things get really interesting. Researchers have actually done it. They've created a new fiber by directly copying the blueprint of polar bear hair, solving that century-old problem of aerogel's fragility. So here's how they did it. They created a fiber with a strong, flexible inner core, wrapped it in a special insulating polymer shell, and then left the center hollow, just like the polar bear's hair to trap air. It's a direct translation of nature's blueprint into modern materials science. So how well does it work? Well, in a minus 20-degree cold chamber, researchers tested a sweater made from this new fiber. Look at the surface temperatures on this chart. Lower means less heat escaping. Cotton and wool barely stood a chance. A thick down jacket, the gold standard for warmth, came in at 3.8 degrees. But the aerogel sweater? It was even better, at 3.5 degrees. And get this, it achieved this while being just 1/5 the thickness of the down jacket.
For the scientists in the audience, the material achieved a thermal conductivity coefficient of just 0.031. For the rest of us, that number simply means it's one of the best insulators ever created. But now, for the first time, it's in a form that's flexible, durable, and washable. So why does this matter? Well, the applications are enormous. Imagine winter coats that are as thin as a spring jacket, but it goes way beyond clothing. This technology could lead to super insulating building materials that dramatically cut our energy bills, or lighter, more efficient components for aerospace and military applications, where every single gram and every degree counts.
So, the crucial point is this. We started with an animal that has mastered survival in the cold. We looked at a brilliant human invention that had a critical flaw, and by simply mimicking nature's blueprint, a design perfected over eons, we finally solved an engineering problem that's existed for nearly 100 years.
This really points to a much bigger idea. It makes you wonder, what other profound solutions are hiding out there in plain sight? What other blueprints are just waiting for us in the wings of a butterfly or the leaves of a plant, ready to solve our next great challenge if only we look close enough?
Don't go anywhere, hit subscribe and we continue.
You know, when you think about how we build things, it's all about brute force, right? We use these rigid beams, heavy materials, a lot of straight lines. But nature does something completely different. It builds with information. It uses an elegant code, a set of simple geometric rules repeated over and over to create structures with a kind of complexity and resilience that we can only dream of. Just look at this. On the left, you have a seashell. A structure so perfectly designed it can withstand the crushing pressure of the deep ocean, perfected over millions of years. And on the right, the Tacoma Narrows Bridge, a supposed marvel of modern engineering that literally twisted itself to pieces in a 40-mile-an-hour wind just 4 months after it opened. Seeing these two side by side, well, it really makes you stop and ask a pretty fundamental question. I mean, why is that? Why can our most advanced, expensive, and celebrated designs have these catastrophic hidden flaws, while nature's designs just seem to get it right every single time? Well, the answer, it turns out, lies in a completely different way of thinking about engineering. So let's dive into this. To really get where we need to go, we first have to be honest about where we've gone wrong, and it's a recurring theme in our history. The history of engineering is unfortunately riddled with these moments of failure. I mean, think about the I-35W bridge in Minneapolis back in 2007. The entire thing collapsed during rush hour because of a single steel plate, a gusset plate that was just a little too thin. It's a chilling reminder that our approach often misses the subtle forces, the elegant efficiencies that nature mastered eons ago. Okay, so what if we've been looking at this all wrong? What if we stopped trying to conquer nature and instead started learning from it? What if we saw the living world not as a pile of resources, but as a library of proven, time-tested solutions to pretty much every problem we face? And that brings us to this incredible idea, this concept called biomimicry. It sounds fancy, but it's a beautifully simple and profound idea. Instead of trying to invent everything from scratch, we look to the natural world for inspiration that has already been tested, refined, and perfected. And just try to wrap your head around the timescale we're talking about here. Life on Earth has had 3.8 billion years of research and development. Every single living thing you see around you is a survivor. It's the end product of relentless trial and error. That is, without a doubt, the most powerful engineering lab imaginable. And let's be real, nature's solutions are just unbelievably sophisticated. It figured out how to create incredible strength with all the weight, how to self-assemble complex structures, how to self-repair, and it does it all while being perfectly sustainable. So the most obvious place to start is simply by looking at shapes, right? Just copying the forms we see in the natural world. But here's what most people don't realize. Even at this basic level of imitation, the results are absolutely revolutionary. Okay, check this out. It's one of my favorite examples. You've got Japan's super fast bullet trains. For a long time, whenever they shot out of a tunnel, they created this massive sonic boom that would rattle entire neighborhoods. So what did they do? The engineers studied the kingfisher, a bird that can dive into water with almost zero splash. They redesigned the nose of the train to mimic the exact shape of the bird's beak. And guess what? It didn't just solve the noise problem, it made the train 10% faster and cut its energy use by 15%. Amazing! Or how about this one? A huge problem in hospitals is infection. So instead of just developing more chemicals, researchers look to sharks. A shark's skin isn't smooth. It's covered in this unique microscopic pattern that bacteria and barnacles just can't stick to. So a company called Sharklet replicated that exact texture onto a new material. The result? A surface for medical devices that naturally repels bacteria. No antibiotics, no chemicals needed. A physical shape solving a chemical problem. It's genius. But here's the thing. Copying shapes, that's just scratching the surface. The real revolution, the hidden code we're after, it isn't just about what nature builds. This detail changes everything. It's about the underlying rules it uses to build them. And this is where things get really, really interesting. We're finally beginning to uncover the fundamental math, the hidden geometry that governs all the strength and efficiency we see in the natural world. These are the secrets we can finally start applying to our own world.
Okay, principle number 1 of nature's secret code, fractal geometry.
So what's a fractal? It's actually a pretty simple idea. It's just a pattern that repeats itself over and over at smaller and smaller scales. Think of a tree, right? The trunk splits into branches. Those branches split into smaller branches, and so on. Well, as you can see here, the Eiffel Tower uses the exact same logic. Its large trusses are made up of smaller trusses, which are made of even smaller ones. This self-repeating pattern is incredibly efficient. It distributes stress across the entire structure, making it unbelievably strong while using way less material. All right, you ready for the next piece of the puzzle? It's a principle called Gaussian curvature. Now, that sounds complicated, but I promise it boils down to something really simple and elegant: the power of the double curve. Okay, think about it like this. Take a regular piece of paper. It's totally flimsy, right? Now curve it in just one direction, and it gets a little bit stronger. But here's the magic trick. Curve it in 2 directions at the same time, like the surface of a seashell or an eggshell, and suddenly it becomes incredibly strong. This double curvature distributes forces across the entire surface. It's how nature creates immense strength from very thin, lightweight materials. Okay, so what happens when we take these ancient principles, this fractal geometry and this power of the double curve, and we combine them with our most advanced technology, like computational design and digital fabrication? Well, we get a whole new generation of architecture, one that feels less built and more grown. Take a look at this. It's called the shell-lace structure, and it's a perfect example. By studying the precise geometry of seashells and then using computers to optimize it, architects can create these incredibly light but super strong perforated structures. It's this perfect fusion of nature's deep efficiency and modern manufacturing. And we can go even deeper, right down to the microscopic level. This is the trabecula pavilion, and it's inspired by the inside of our own bones. See, bone isn't a solid block. It's this porous, intricate web that only puts material exactly where stress occurs. By mimicking that with 3D printing, we can design structures that use a tiny fraction of the material but have all the strength we need. And look, this isn't just for cool-looking pavilions. We can apply this very same logic to our biggest structures, our skyscrapers. Imagine high-rises with exoskeletons that mimic the fibrous strength of a plant stalk. They would be lighter, they'd use far less concrete and steel, and they would be way more resilient, swaying in the wind instead of fighting against it. This is literally the future of our city skylines. So what's the big takeaway from all of this? Here's what's so important to realize. Biomimicry is so much more than just making buildings that look like seashells or plants. It's a fundamental shift in our thinking. It's about designing for efficiency, for resilience, for sustainability. It's about finally seeing nature as a mentor, not just as a resource to be plundered. For centuries, our whole approach has been about defying nature, trying to impose our will on the world. But the evidence is crystal clear. Our greatest achievements, our most enduring structures, they won't come from conquering the natural world. They'll come when we finally learn to collaborate with its 3.8 billion-year-old wisdom. The blueprint has been right in front of us the entire time. We just needed to learn how to read it.
Don't go anywhere, hit subscribe and we continue.
You know, you can imagine a creature that just defies death itself, an animal so tough it can survive the frozen emptiness of space and the crushing pressure of the deep sea. Well, that's not science fiction. Here's what most people don't realize. This tiny, microscopic animal holds a biological secret, a hidden power that could fundamentally change everything from medicine right here on Earth to our ability to travel out there among the stars. And look, that's not an exaggeration. We usually think of, lions or bears as the toughest things out there. But forget all that. The undisputed champion of survival is smaller than a grain of sand. So what exactly are its superpowers? I mean, just look at this list. It's a long one. They can be completely dehydrated for decades, decades, and then just spring back to life with a single drop of water. They can handle the vacuum of space, brutal heat, extreme cold. But it's that last one on the list, that's the one that really got scientists' attention. It's almost impossible resistance to radiation. Let's just sit with this number for a second. Minus 458 degrees Fahrenheit. That is just a tiny fraction of a degree away from absolute zero, the temperature where the universe itself pretty much just stops. And yet, the tardigrade just shrugs it off. Okay, now for radiation, for a human, a dose of just 5 to 10 grays is fatal. Done. Tardigrades, they can withstand 5,000. That is not just resistance. That's like having a biological fortress built into your very cells. And figuring out how they build that fortress, well, that's what has scientists so fascinated. And that really is the billion-dollar question, isn't it? How in the world does a tiny little water bear pull off these miracles? Well, the answer isn't magic. It's actually a masterpiece of molecular engineering, a secret that we are only now beginning to unlock. The first clue to cracking the tardigrade's survival code wasn't found in its tough little exterior, but deep, deep inside its cells. The secret, as it turns out, is all about a very special set of proteins. So after sequencing its genome, researchers found this whole suite of unique proteins, but two just jumped right off the page. You've got Cas proteins, which protect them from drying out, and then this one-of-a-kind protein they named DSUP. It's short for damage suppressor. And yeah, it does exactly what the name promises. Honestly, this is the best way to think about it. DSUP doesn't just block a little damage here and there. It physically wraps itself around the tardigrade's genetic code, creating this form-fitting shield. It's literally like putting a suit of high-tech armor on the most vital and the most vulnerable part of the cell, the DNA. And here's how that armor actually works. When radiation slams into a cell, it creates these tiny invisible destroyers called hydroxyl radicals, and they just shred DNA on contact. But DSUP sees this coming. It physically binds to the DNA's packaging structure, it's called chromatin, and it forms this protective cloud that just deflects those radicals before they can do any harm at all. Then you've got the other key protein, Cas, and it uses a totally different but just as clever trick. See, when a cell dries out, all of its internal structures can collapse and shatter. Cas proteins form this gel-like scaffold inside the cell. You can think of them like molecular packing peanuts that just holds everything perfectly in place until water comes back. So, okay, the tardigrade has these incredible custom-built survival tools. And this lets scientists to ask a really mind-bending question. Are these powers exclusive to the tardigrade, or could they actually be transferred? And this is where things get really interesting. In a stunning experiment that sounds like something straight out of a comic book, researchers took the genes for these tardigrade proteins and they put them into human cells grown in a lab. They essentially gave human cells the tardigrade's superpowers. The big question then became, would it actually work? The results were frankly remarkable. When they subjected the cells to stress, in this case a lack of oxygen, the normal human cells died off at a really high rate. But the cells that were enhanced with the tardigrade's DSUP protein, they showed a dramatically higher survival rate. The armor worked in a human cell. And what's wild is that it wasn't just a passive shield. The DSUP protein actually helped the human cells fight back. It neutralized these damaging particles known as reactive oxygen species, and it supercharged the cell's own natural antioxidant defenses. It made the human cells tougher from the inside out. Now, this wasn't just some cool lab trick. This discovery has immediate and profound implications for the real world. It all starts with a potential revolution in medicine. To understand why, you gotta look at a major challenge in global health. A lot of our most advanced medicines, like vaccines or treatments for hemophilia, are incredibly fragile. They're biologics, and they break down super fast unless they're kept in what's called a constant cold chain of refrigeration. And this is where the tardigrade's other superpower comes in. Remember the packing peanuts? Researchers took that fragile medicine, they mixed it with the Cas-HS protein, and they dried it all out. The result? A perfectly stable, room temperature medicine. This could get life-saving treatments to disaster zones, to battlefields, to remote villages, anywhere that refrigeration just isn't an option. And the potential applications here are just vast. I mean, imagine vaccines that don't need to be frozen, making them so much easier to distribute around the globe. Or think about blood products, stem cells, antibodies,
All of it could be stored for long periods without needing expensive, energy-guzzling freezers. This could truly change the face of modern medicine.
But the implications of this research don't stop at the edge of our atmosphere. Oh no, they go way beyond our planet, pointing to a future where the tardigrade secrets could help us finally reach for the stars. Once you leave the safety of Earth's magnetic bubble, space is basically a shooting gallery of high-energy radiation. For astronauts on a long trip to, say, Mars, this constant bombardment isn't just a risk, it's a certainty. And it poses a huge threat to their health and to their very DNA. And look, this isn't some theoretical problem for a far-off future. NASA is actively trying to solve it right now. The Cell Science 04 experiment is literally flying tardigrades on the International Space Station to learn exactly how they cope with that double whammy of microgravity and space radiation. I just love this quote from the lead scientist, Thomas Boothby, because it perfectly captures that pure excitement of discovery. He says, "We want to see what tricks they use to survive. We just don't know what to expect." They're watching in real time, trying to find the master key to surviving in space. And that's the ultimate vision here. The same proteins that can make medicine stable on Earth could one day be used to make our food, our supplies, and maybe even our own cells more resistant to the brutal environment of deep space. The tardigrade survival kit could become humanity's survival kit. So it all comes back to this one tiny, seemingly indestructible animal. From a clump of moss in your backyard to the high-tech labs of the International Space Station, the tardigrade is showing us a whole new blueprint for what it means to be resilient. And it leaves us with a truly fascinating thought. Could the secrets of Earth's smallest superhero be the very key that unlocks humanity's greatest adventures?
Thanks for watching. Support BioVellum by liking, subscribing, and sharing. Let's explore the secrets of nature together.